Many reactions that are favorable, in other words, have a negative enthalpy and a positive entropy, do not occur on their own at room temperature. These reactions need to be activated, or energy needs to be added to increase the frequency and force of molecular collisions. The energy required for a reaction to be activated is known as the activation energy. On the slide are two potential energy diagrams, one for an endothermic reaction and one for an exothermic reaction. The y, or vertical axis, is the potential energy, and the x-axis is the progress of reaction. The diagram on the left is the endothermic reaction, and the curve begins at the potential energy of the reactants, or the energy stored in the reactant bonds, and ends at the potential energy of the products, or the potential energy stored in the product bonds. Notice that the potential energy of the products is higher than that of the reactants, and this is an endothermic process. The difference between the potential energy of the reactants and that of the products is the enthalpy of the reaction. This little hump above the highest energy is the activation energy of the reverse reaction. The energy from the reactants up to the top of the hump is the activation energy for the forward reaction. We'll talk more about forward and reverse reactions, but chemical reactions can proceed in both directions. The activation energy is what is needed for reactants to collide with enough force and enough frequency so that proper collision is attained and product bonds form. The diagram on the right is an exothermic reaction, since the products have less potential energy than the reactants. The difference in energy between the reactants and the products is the enthalpy of the reaction. The difference in energy from the products up to the top of the hump is the activation energy of the reverse reaction, while the energy from the reactants to the top of the hump is the activation energy for the forward reaction. The activation energy is symbolized by capital E subscript A and can be thought of as a barrier for reactants to overcome to reach products.